Hello, Honors Higher Algebra students. This is Mr. Johnson, and this is the 7th and the last lesson in our Unit 16 study of statistics. This particular lesson, we're going to look at the line of best fit, which I mentioned a number of times in the last video. And so I think you'll find this part pretty interesting. Your calculator does a lot of the work for you. So I'm back kind of in this model where I have the calculator shown. I will do my best to do a little bit of writing in the notes as well, but I'm going to mostly just talk through a number of these things. So the first thing we're going to talk about is, what the line of best fit is and how to draw that. We're going to start by basically estimating this, and then we're going to talk about how your calculator can actually do it for you. Okay, so when we talk about our linear regression, we talk about data in a scatter plot. We're looking specifically at does this data kind of relate to each other? Is there some sort of correlation there? Is the R value either really close to 1 or really close to -1? Is there a strong correlation? And so when we look at our data, we think of a linear model. And so what we're going to do now is actually plot that linear model on this set of data. So the first thing to do is to calculate the mean of both your horizontal axes, which is what we're going to call x, and your vertical axes, which we'll call y. That's that little x and y with a little line over it there, that little hat. That's going to be the mean point. So you're going to draw the mean point in, and then you will draw a line that best fits the data, just kind of by eye, basically. And then we'll look at how the calculator can do this not exactly, but the calculator can do this using a pretty extensive formula. The line of best fit that we're going to be able to calculate on our calculator is a little bit different here with regard to the approach of just kind of eyeballing it, I guess you could say. The line of best fit using the method of least squares is a really complicated formula where it essentially takes a look at every data point within our scatter plot, and it looks at how far off that data point is from a particular line, and it tries to take a line through the data that gives the best approximate with an account of every piece of data within that particular scatter plot. So it's kind of an amazing calculation, and your calculator does this in a split second. It just crunches all of these numbers, and it kicks out the line of regression, which I will show you how to do in just a moment. Okay, so let's go into our calculator, and we'll do some kind of random data, I guess. So if you go into Stat and into Edit here, you can enter in some random data. Let's just do just a few different pieces of data here. Maybe I'll just do 5. I know that's not very much, so it's going to be kind of weird how that's going to look, but that's okay. And then we'll do, I'm not going to do real big numbers, but we'll do something that's a little bit bigger here than the other set. And I don't have any idea if this is going to be correlated well or not, but we will find out. Actually, I'm noticing right now that it's not going to probably look very nice. I'll do that so that it helps a little bit. Okay, so let's take a look first at our plot. Now remember, you can go to second and y equals. You can turn on your plot, and you can choose the scatter plot, which is that first option there. You can choose L1 and L2 for L1 for X and L2 for Y. You can choose your little symbol, and then you can choose your color. The window, boy, I already forgot. I'm just going to go from 0 to 10, and then I think I'm going to go from 0 to 20, because if I remember right, everything that I put in there kind of randomly should fit. And then we should be able to plot this. Ooh, that's not looking very good. However, and actually, hold on, let's go back here to our menu. Okay, so it's looking like it's probably going to have a negative correlation, because it looks like it's going down like that. Not terribly great, but again, it's not very much data. So we don't have a lot to work with. But when we're looking at this in our calculator, we can find this LINREG, this line regression. And that line regression is in your stat menu under calculate. And if you go down to 4, this is the same exact one we used in the last lesson to find R. What I'm going to ask you to do, though, is something a little bit new. It says store regression equation. And we're going to store this in Y1 because we're going to let our calculator just automatically graph it for us. So if you press alpha and F4, which is the trace button, and choose Y1, what it's going to do is it's going to find a line, and then it will also just kick that thing right into your Y equals, and it will graph it for you. So go ahead and hit enter. It will give you the equation of a line, and it will give you A, and it will give you B, which will develop the line itself. Now, if I go to my graph, you can see that it draws in the line, because let me go back to Y equals really quickly. So it actually plugged that in automatically to my Y equals, which is really cool. And so when you go to graph, then you can actually see that line in that set of data, which is really neat. So anyway, that's kind of that was just a random example without a whole lot of data, which was not very helpful. One other thing I want to show you really quickly is to get the mean point. So if you go to your home screen again, go to Stat, and over here at Calculate, we have done the one variable stats before, which does give you the mean and different things like that. We are now living in the two variable stat world at this point, so we're going to have our two variable stats. We're going to go ahead and hit Calculate, and you'll notice that you get X with a hat on it. That's 7.4. That's the average of X. Average of Y is down here. You do get standard deviations for each of those and all sorts of things. You get the minimum maximums. But anyway, to get that mean point, that average point, you can just do the two variable stats button, and it does it really quickly. Okay, so we're going to take a look at this example, and we're going to come up with a line of best fit for this. Okay, so what I want you to do is go to your calculate menu. I'm sorry, not your calculate. Go to your stat button, go to your edit menu, clear out L2, press clear and hit enter, clear out L1, clear, enter, and then let's go ahead and just type in this data. And what I'm going to do is I'm going to pause and finish this off. Okay, so I have my data in my table. So I have L1 for the total fat and L2 for the total calories. And so then what I want to do is find an equation for the relationship between these two lists. So we're going to go into, so I'm going to press second quit again. I'm going to go into Stat menu. I'm going to go over to Calculate, and I'm going to go down to option 4, which is the line regression. Yes, I want all that good stuff. I'm going to go ahead and store this guy right in Y1, which would be really helpful because then we can just immediately graph it without having to worry about much else. Hit Calculate, and there you go. You have your line with A and B, and if you go to Y equals, it will automatically be right there for you. Okay, so let's go to our window and take a look at this. So my input values there are anywhere from 5 to like maybe 34 or so. So I'm going to go from 0 to, let's make this 40. That'll be easy. And then for Y, I know our minimum is in the 200s, but I'm going to go from 0 just so we get a little bit of everything. And then we have to go all the way up to about 600. Let's go 625 though, just so that we have a slightly larger window. And so we'll hit graph and see what happens. So there we go. We can see a nice correlation there, a nice line of regression, and it goes through, some of the data even. That line of regression doesn't really need to go through any data, so just keep that in mind. It might, but it doesn't have to, because remember, it's calculated by looking at the distance from the data itself. So that's a little bit different maybe than possibly what you're thinking. You don't have to connect any of those points. It just simply is the line that just does the best it possibly can to go through that data. Okay. All right. So we have an equation for that. Now, when we use this line of regression, it allows us to now estimate other elements of the particular scatter plot. So if we're looking, for example, if we take a look at this particular scatter plot, if we're looking within the data, we can use the regression to estimate another point within that data. So it's kind of embedded within the data. Maybe it's something that's just in between some of these points, and we're using the line to estimate within the actual data that was either studied or gathered and that kind of thing, okay? Interpolation is the term used for that. Extrapolation is on the outside of that, and so those values we could also use as an estimate, but they may not be quite as accurate because maybe the data we gathered is really only good for that particular range, and maybe something on the outside of this is not as nice. But you can use your line of regression to estimate any one of these things and kind of predict it and estimate it based on what the trend happens to be. So let's take a look back on this particular example. Now we have a new equation written in here. I'm pretty sure that our value is very close here. We have 11.731 and 193 point something or other. So this equation is just sort of a nice little rounded estimate for that. But either way, you know, if we're taking a look at, for example, a Whopper at Burger King has 40 grams of fat. Estimate the number of calories in the Whopper. Okay, well, let's take a look at our equation. I'll do this on the calculator. So we're looking at the total amount of fat is 40 grams, and we're using this estimate here. Actually, you know what? I'm changing my mind. Okay, I'm going to use our equation that's here because it's the most accurate based on our data. And I'm going to show you a cool trick. So if you press if you press alpha and trace and y1 like that, you can put in parentheses 40, and that's function notation for take 40 and plug it in for x, and you're going to find the total number of calories. So it's a nice little shortcut, and it uses our equation in y equals, which is the regression equation that we developed, so it's kind of accurate there. So we get 663.103. So you could just round that. 663 is probably fine there. That's the estimated number of calories in the Whopper based on our regression line. Okay, so you can put that in there. I don't know if I can write on here. Let me try. So 6, oh, it's really ugly, but I can sort of do it. Oh, not really. Okay, well, I give up. That's 663. I'm gonna kind of stop with that. Okay, so let's take a look at the second one. So a grilled chicken sandwich at Burger King has 430 calories. Estimate the number of grams of fat in grilled chicken sandwich. Okay, so this is where we have y. So we have the calories. So on our calculator, and I'm not going to attempt to draw it again because that didn't work very well. So we have 430, and we will first subtract 194. So I'm going to use this linear model here just because that's what we have available, which again is pretty close. It's just slightly rounded. And then we're going to divide by 12. And so our estimate is that there's going to be about 19.67 total grams of fat in that sandwich. Okay, so which of these estimates above will be considered the most reliable? Well, it's going to be the ones that are within the data, which is going to be the second one. So the first one, notice that 40 grams of fat is nowhere on this table. In fact, it's above the maximum by a fair bit. 430 calories certainly is within all, a number of these. It's within our data that we were studying. And so this is probably more reliable than the Whopper just because it's within the data that we gathered. All right, let's take a look at this one. So it says, on a hot day, 6 cars were left in the sun in a park. Length of time each car was left in the sun was recorded, as well as the temperature inside the car at the end of the period. So we have all that data in. We're going to go and enter this in. So I'm going to clear this, and I'm going to go to my stat button, go to edit. I'm going to clear list 1. Sorry, I'm in list 2. Clear list 1, and we'll go ahead and enter in this data. So I'm just going to put time as the x because that's what it says in the table. So we have 50 and 5 and 25 and 40, 15 and 45. And then over here we have 47, 28, and 36, and 42, and 34, and 41. Okay, calculate the average of each. Okay, so if you remember, and I'm going to go to second and quit. So we go to our stat button, we go over to calculate, we go to 2 variable stats, hit enter, and calculate. And you can see that the average x, and I'm going to have you write these in because I'm not going to attempt to write these. So the average is 30 for the time, and the average y is 38. And so that's our average point. I am going to try to graph that. So x is 30 and y is 38. So I'm going to say that's about right there. Okay, so I put just a little dot right there. And then I'm going to have you kind of do this because I'm afraid I'm going to completely mess this up if I draw this. But, if I was to eyeball this line of regression, it would be like this, right? It would be through that point, and it would kind of try to do the best it could to sort of split the data. So you just try to get the nicest line through that mean point. Okay, so find an equation for the line of best fit. So I'm going to go to my calculator and let it do its work. So I'm going to go to stat. I'm going to go over to line of regression, and I'm just going to simply calculate this guy so I get that. Okay, so we have our line of regression. We have the mean points there, the averages. And again, you guys can draw that line right there. That would be the line of best fit. Okay, so we're going to predict, predict the temperature of the car. Predict the temperature of a car which has been left in the sun for that amount of time. Okay, so we have our equation here. And what I'm going to do next is I'm going to go ahead and take the 35 minutes as x. So we're going to take 35. And you know what I'm going to do? Hold on. I didn't do this before. I realized. Did that and that. I didn't store it. So I'm going to store it as y1. So make life easier. Okay, there we go. So we have our y1, we have our equation in there. So I'm going to let x be 35. And that way I can just go to my y1 on my home screen. I can simply just type in 35. And I have 39.82, and so that's going to be the predicted temperature. That's going to be for this first one. And then you could do the same thing. You could go like this, and you could do 75, and you get that 54.45. So that's going to be for the second one. Okay, so in terms of the reliability, same thing as the last problem. We're going to say that the first one is reliable, or more reliable, because 35 minutes does fit within our data. But 75 minutes is quite outside the data, and so it doesn't probably give us much reliability with regard to the trend of this particular data. So you have to kind of make sure that you trust your data by picking pieces of data that are within your study, not outside of your study. Okay, and that's it. So then you have your homework, and that is the last lesson in Unit 16. Thank you.